In a fleeting, inexplicable moment, humanity vanishes from Earth, leaving a silent planet behind. Artificial lights flicker like fading memories of a lost civilization. Neon-lit cities pulse with vibrant colors, while tiny LEDs shine at remote observatories. Even eerie green glows from nuclear witch vaults persist without their creators. The question looms, when will the last artificial light fade? Its answer unveils a journey through physics, engineering, and time's relentless march. Within 24 hours, 90% of the global power grid collapses due to load imbalances. Megacities like New York and Tokyo plunge into sudden darkness. Coal and gas plants halt without human refueling or maintenance. Nuclear reactors, though advanced, shut down automatically for safety. Surprisingly, the most enduring light isn't from solar panels or hydroelectric dams. It's the radioluminescent glow of cesium-137 buried in storage vaults. Cesium-137, with a 30-year half-life, glows faintly green for over 200 years. Radioactive particles excite surrounding glass, producing light without electricity. Solar panels succumb to desert dust. Wind turbines break in storms. Yet nuclear waste light persists, humanity's eternal flame. Nuclear waste, once deemed hazardous, becomes our final illuminated legacy. It reminds us of humanity's ingenuity and its flaws. This journey traces a timeline where each second lights extinguish one by one. From collapsing grids to enduring solar panels, we witness nature's ascending to the faint green glow below. We see artificial systems defy nature's wrath. Could a flashlight in a drawer outshine radioactive glass? Step into this story where science and time reveal light's fate. Join us to uncover humanity's final legacy on an unwitnessed Earth. Science and time unveil the last light's enduring tale. The gradual extinction of artificial light. In the first hour after humanity vanishes, cities glow with neon and LED lights. Beneath this calm facade, the global power grid begins to falter. Coal, gas, and nuclear plants face load imbalances without human oversight. Frequency fluctuations trigger automatic shutdowns within 30 to 60 minutes per IEE studies. Automated systems detect minor faults like unstable pressure sensors or stuck valves. Without human intervention, these errors cascade like cracks in glass. Nuclear reactors shifted to low-power mode, a safety designed to maintain stability. Their cooling systems, reliant on external grids or diesel backups, face time limits. Advanced AI monitoring systems send alerts into the void, receiving no response. In rural areas, fluorescent farm lights linger on dwindling power reserves. After 24 hours, 90% of the global grid fails, per NERC research. A domino effect darkens New York, Tokyo, and Paris, leaving only backup-powered specks of light. Coal and gas plants needing constant fuel supply halt as pumps clog or tanks empty. Without humans, they become lifeless steel husks. On remote Pacific islands, diesel generators power simple bulbs for days or weeks. Fuel tanks of 510,000 liters run dry at 10 to 50 liters per hour. At Antarctic research stations, LEDs shine on lithium-ion batteries, draining 2 to 10% yearly. Their maximum lifespan rarely exceeds a decade, per Battery University. In small towns, traffic lights on lead-acid batteries flicker for 1 to 3 days. Their 100-200 Ashi capacity empties swiftly without recharging. 1 week passes and nuclear power plants, despite maximum safety designs, begin to fail. Emergency cooling systems using diesel generators or batteries deplete fuel or energy in 3-7 days, triggering a scram, per IAEA standards. No reactors operate beyond this point, though their uranium cores could power for years if maintained. In Iceland, geothermal plants still generate electricity, lighting abandoned villages. Geothermal systems require periodic maintenance, like gearbox oil changes and joint lubrication, every 6 to 12 months. Without it, pumps and valves fail within 1 to 2 years, halting operations. Wind turbines like Vestas Vianati in Denmark and Texas keep spinning, powering red beacon lights. Automatic lubrication allows 3 to 5 years of operation without maintenance per NREL research. Bearings and blades wear down mechanically, especially in high wind regions, causing turbines to stop. In Chile's Atacama Desert, solar panels with 20 to 25% efficiency power small LED weather station lights. Inverters and controllers, per the Solar Energy Industries Association, last 10 to 15 years. In rural areas, flashlights dim as alkaline batteries lose 10 to 20% charge yearly, per Energizer data. After 1 month, most diesel generators on the remote islands exhaust fuel, except the 1,000-liter tanks lasting 2 to 3 months at low consumption. Mechanical failures like clogged oil filters from continuous use also cause breakdowns. Large hydroelectric dams like Hoover Dam operate automatically but face excess power from unconsumed loads, overloading transformers in 1 to 2 years. Silt and debris clog intake, reducing the efficiency. City LED billboards go dark as backup lead-acid batteries deplete in 1 to 2 weeks. Battery-powered devices like alarm clocks or nightlights lose 20 to 30% energy, limiting remaining time. Remote solar-powered emergency lights persist, weather and controller durability permitting, lasting 5 to 10 years. After 1 year, the artificial light landscape grows bleaker. About 80% of wind turbines stop due to bearing wear or blade fractures in storms exceeding 25 milliretz. A few in low-wind Denmark persist up to 5 years. Geothermal plants in Iceland and New Zealand halt from pump corrosion or clogged steam pipes after 1 to 3 years without maintenance. Small hydroelectric dams stop as silt accumulates 1 to 2 centimeters yearly. Large dams risk turbine failure from excessive vibration or bearing wear. Solar panels in arid Mojave maintain 90-95% efficiency, degrading 0.5 to 1% yearly per NREL. 10-20% of solar systems fail from inverter breakdowns. Most alkaline and lithium-ion batteries in flashlights and appliances deplete or corrode, ceasing to light. After 10 years, most hydroelectric dams stop from intake clogs, with 10-20 centimeters of silt, or turbine wear from bearing corrosion. Only 1-2% of large dams like China's Three Gorges may last 20 years due to optimal design. All wind turbines halt, none surviving a decade without maintenance due to bearing or blade failures. In Antarctica and the Gobi Desert, solar panels retain 80-85% efficiency, powering 1 to 5 WLEDs. 90% of solar systems fail from controller corrosion or electrical connection decay. In cities, no fluorescent or LED bulbs function, broken by cracked glass or corroded circuits. Underground, the green glow of cesium-137 in glass blocks at Yucca Mountain shines prominently. With a 30-year half-life, its radioluminescent intensity halves in 30 years but remains visible. After 50 years, solar panels degrade to 50 to 60% efficiency due to material delamination or cracked photovoltaic cells. Only 1-2% of systems in arid regions like the Mojave Desert still power faint LED lights. Human-made structures from hydroelectric dams to geothermal plants and wind turbines become ruins due to corrosion and structural collapse. Some beacon lights on telecom towers using 0.1-0.5 W solar panels still flash in remote areas, but their numbers are negligible. Radioluminescent light from cesium-137 drops to 12.5% of initial intensity after 90 years, corresponding to 3 half-lives. Storage vaults, designed to prevent leaks and withstand millennia, ensure this light remains uninterrupted. On the surface, vegetation and weather erase most traces of artificial light, except for a few exceptional solar systems. After 100 years, nearly all solar panels cease functioning, with efficiency below 20% due to material degradation or a complete controller failure. Only 1% of systems at high altitudes like the Andes produce minimal power. No LED bulbs shine on Earth's surface due to power loss and physical damage. Underground, cesium-137 maintains 10% light intensity after 100 years, corresponding to 3.3 half-lives. Storage vaults, designed for 10,000-year durability, shield radioluminescence from groundwater and earthquakes. Earth becomes a natural ecosystem, with forests and grasslands covering cities, erasing surface artificial light. After 200 years, cesium-137's radioluminescent light is the only artificial source left. With intensity reduced to 1% after 6.7 half-lives, the faint green glow persists in storage vaults. All surface solar panels and LEDs fail due to dust, corrosion, and environmental factors like earthquakes. Storage vaults designed to resist water and seismic activity ensure this light persists for centuries. Earth is now a wild world, dominated by natural light from the sun, stars, and lightning. Only the green glow, hidden deep underground, continues to tell the story of a species that once illuminated the planet. The story of artificial light after humanity's disappearance reveals the fragility and resilience of human-made systems. Based on physics and engineering principles, cesium-137's radioluminescent light with a 30-year half-life endures at least 200 years at 1% initial intensity. Other light sources, like solar panels, 50 to 100 years, hydroelectric dams, 10 to 20 years, wind turbines, 3 to 10 years, and batteries, 5 to 10 years, fail earlier due to maintenance needs and environmental impacts. Nuclear waste storage vaults, engineered for millennial durability, ensure this green glow is humanity's final legacy. Earth, without humans, reverts to a natural world, but underground radioluminescent light whispers of a time when humanity mastered light.